Okay, guys, yet again we have another chemical equation. This one, in terms of difficulty, I would put it at, on a scale of 1 to 5, it's at about a 4. So here we have um, ammonium that is about to react with copper oxide, which gives us the product of copper, nitrogen, and water. And so now we want to begin balancing this equation. So we have a lot of elements here, and as I'll remind you, as I did last night, we don't want to think about these as compounds. Now that we're balancing the equations, we want to think about these as individual elements. So this is no longer considered, for the moment, ammonia. It is considered nitrogen with 3 hydrogens. So what we're going to do again is, as I did in the last video, is we're going to separate our reactants from our products. So I'm going to draw this line, and now we can begin. We have a nitrogen, we have a hydrogen on this side, we have a copper element on this side, we also have oxygen on this side. Okay, and the same over here. So I'm going to do that over here as well. And I'm going to stress that you guys do the same thing, especially when you do your exam. It's a nice way for you to organize and ensure that you're keeping up with what you have on this side as opposed to this side. Again, it's a nice way to organize and know exactly what elements need to be balanced on either the left or the right. Okay, so here, as you see, we only have 1 nitrogen element. So we put a 1 there. We have 3 hydrogen elements here. So we put a 3 here. Copper, we have 1. And of course, oxygen, we have 1. Now, let's see how many we have on the product side or the right side. For copper, we have 1. For the hydrogen, we have 2. Nitrogen, we have 2. And oxygen, we have 1. Right? Okay. Now, let's just do our checks and balances, okay? So on the reaction side, or the left side, we have 1 nitrogen. On the product side, we have 2. So let's go ahead and fix that. So automatically, we know that it's not balanced because we have 2 on the right and we have 1 on the left, right? So we're going to put a 2 here. Maybe I should use a different color so that stands out. So we're going to put a 2 there, okay? And so now we're going to cross that out and change that to 2. But now when we add the coefficient of 2 here, then our hydrogens on this side change, right? So now we have 6 hydrogens on this side. So we need to mark through this, and we have 6 hydrogens on this side. Now we have 2 hydrogens on the right side. So to get 6, so that this is balanced, what do we need to multiply this hydrogen to get 6? Again, redundant, I know, but I'm going to have you do it. 2x is equal to 6. And so x is equal to 3, right? So we know that we need to add 3 here to get 6. So we'll change that to 6. Also, what happens now that we have a coefficient of 3 in front of the water molecule, that means that we multiply this by this, which is understood as 1 oxygen. So now 1 times 3 is 3. So we have 3 oxygens over here. So we can change that to 3 on this side, right? So far, so good, right? But now, if we look at our oxygens, we have 3 oxygens on this side now, and we have 1 oxygen on this side. So we need to balance. On this side, we need 3 oxygens over here on the left, right? So right away we have a coefficient of 1 here. So in order to get our 3 oxygens, then 3 times 1 is 3. So we put a coefficient of 3 here. So now this goes from 1 to 3. So our oxygens are balanced. But, as I'm pretty sure you're catching me, we now have 3 coppers, because obviously this coefficient is going to be multiplied by both of these elements here. So we have 3 times 1, which gives us 3 coppers. 3 times 1 for the oxygen gives us 3 oxygens. So we change this 1 to a 3, right? Now, if we look at our coppers, we have 3 coppers over here after balancing our oxygens, and we have 1 copper over here. But it appears that we've lucked out because we have a single copper over on the right side. So all we have to do to balance this equation is add a 3 here. Now let's give ourselves a check. So we have 2 nitrogens on this side, 6 hydrogens on this side, 6 hydrogens on the right. We have 3 coppers on the left. Now we have 3 coppers on the right, 3 oxygens on the left, and 3 oxygens on the right. So I think that it is safe to say that this chemical equation is balanced.